Okay, today we're going to look at using our exponent rules, but we're going to do some harder examples. So it's helpful to have your handy dandy table available. It's also helpful to have your rules written out somewhere to look at as you're practicing them. You don't need to, but it is helpful. So let's get right to it and let's try some examples. So first off, let's try one that's similar to question number 6 on page 236. And let's say we are going to do bracket x to the 5 bracket all to the exponent 2 over 10 times x to the 8 bracket negative 1/4. So we got a lot going on in this question, and all we want to do is just simplify it using our exponent rules. When we're simplifying, we want to make sure we have positive exponents as our answers, and we want to make sure we don't have any decimals. So let's first apply our exponent rules. So this is on the outside, this is on the inside, so we would multiply. So you get 5 times 2 over 10 bracket x to the 8 times negative 1/4. And I'm just going to use brackets just to keep things separate. I find that makes it easier. Example equals x. 5 times 2 is 10. 10 divided by 10. Oh, that's just 1. And then 8 times negative 4, or negative 1/4, gives me negative 2. Okay. It's also possible, if you want, to write to figure out your fraction rules off to the side. So this is where we would use an aside, and we would say, well, that's the same thing as 10 over 10, which is equal to 1. And my other fraction, 8 times negative 1/4. So negative 8/4, which is negative 2. So you can do that. That's totally allowed. Let's finish it off. Now I've got x. So both things have a base of x. They're multiplying, so let's add our exponents. 1 plus negative 2, that's a plus, equals x to the negative 1. Final answer, we want to make sure it has positive exponents. So my final answer for all of this is just equals 1/x. Done. So I just zoomed out here so you can see the full solution. All right, let's try another one. Okay, this time let's do one that's got some root symbols in it. So let's see, we're going to do the 4th root of 4096 times x to the 16. It's all under the root sign. Over 5 root 7776 x to the 30. And again, that's all over or under the root sign. So we got a lot going on in here. We can break this up. So we can think of this as the 4th root of 4096, 4th root of x to the 16. You can totally think of it that way. 5th root of 7776, 5th root of x to the 30. So just like when we were using radicals, when we were just dealing with square roots, same rules apply here. Okay. So let's just extend the page a little bit here. So what does that equal? Well, handy dandy table, the 4th root of 4096 is 8. 8. 4th root of x to the 16. Okay, let's think about that one here. X to the 16 over 4 is one way to write it. The 5th root of 7776 is 6. And the 5th root of x to the 30, let's just write that one in exponent form. Okay, let's just continue the question up here. So I have 8 over 6, x to the exponent 16 divided by 4. So 16 divided by 4 is 4. So I have x to the 4. 30 over 5 is the same thing as 6. So I have x to the exponent 6 in the denominator. Let's simplify out. So let's see. 2 goes into 8 and 6. So I can reduce this one. 2 goes into that 4 times. 2 goes into this 3 times. So you get 4 over 3. And my x's, we're dividing. So let's subtract. So you get 4 over 3x to the negative 2. Final answer, 4 over 3x squared. Good. Okay, let's try another example. This time we're still going to simplify, only now we're going to do, let's see, bracket 2x to the negative 3y squared, all cubed, all over, bracket, x cubed y to the negative 4, bracket, squared. So we have a whole lot of things going on in here. First, let's maybe get rid of these brackets. So the exponent 3 on the outside is going to come in, and it's going to apply to each of the ones on the inside. So that's going to give me 2 to the exponent 3, x to the negative 3 times 3, y to the 2 times 3. Okay, and then let's look at the denominator. So same thing. The exponent on the outside is going to come in, and it's going to hit both of the things on the inside. So that gives me over x to the 3 times 2, y to the negative 4 times 2. Okay, so let's simplify that one up a little bit. So what do we get? 2 cubed is 8. X negative 3 times 3 gives me negative 9. Y to the 2 times 3 gives me a 6. All over x to the 3 times 2 gives me an x to the 6. Y negative 4 times 2 gives me a negative 8. Bring it back up here. So what does that simplify to? We have an 8. We have an x to the negative 9 minus 6, because that's what we do when things are dividing. And then we've got our y's. So I have a y to the 6 minus negative 8. So that leaves me with x to the negative 15. Y to the 6 plus 8 gives me a positive 14. Final answer, 8y to the 14 is in my numerator, and my denominator becomes x to the 15. Well done. Okay, let's try another example. This time it's going to be similar to number 5 on page 235. So that looks like 5th root of x to the 8 over square root of x to the 3, all to the exponent 3. Oh boy, we got a lot going on in here, don't we? I'm going to ignore this 3 on the outside first, and I'm going to simplify what's happening on the inside. I'm going to do that because there's only x inside. So I can definitely do some simplification going on in the inside of my fraction here. So let's see. That equals, I have x 8 over 5 in my numerator. And in my denominator, I have an x that is 3 over 2, because remember there's like an imaginary 2 in there. Not imaginary, invisible 2, understood 2, all to the exponent 3. So when I'm dividing, that means I'm going to subtract my exponents. Remember that rule? So that means I've got x to the 8 over 5 minus 3 over 2. All of that is still to the exponent 3. All right, let's bring it up here to finish it off. Oh boy, fractions. Goodness, let's not do this yet. Let's write this as an aside. Let's do this as an aside. So in my side, I'm going to do 8 over 5 minus 3 over 2. And I'm just going to do it like this because it's so much easier and way less complicated. So common denominator times by 5 times by 5. Common denominator times by 2 times by 2. So what does that give me? 2 times 8 gives me 16 over 10 minus 15 over 10. So this is going to give me a 1 over 10. So my new exponent in there, now we can keep going, equals x to the 1 over 10, all to the exponent 3. Now I'm going to bring that 3 in. So that means I have 1 over 10 times 3. Final answer, 3 over 10. Good. Okay, so let's do one now that looks even a little bit more different. So let's say I have x to the 6, y to the 4, all to the exponent 1/2. And now I want to say I want to evaluate it for when x is equal to 3 and y is equal to 7. So I could sub all my numbers in and just go straight forward like that. So I would have 3 to the 6, 7 to the 4, all to the exponent 1/2. Well, let's see, 3 to the 6 is 729. 7 to the 4th is 2,401. All of that is going to be to the exponent 1/2. Oh goodness, this is getting big. Let's see, we've got equals 1,750,329. My goodness. And then we're going to want to find the square root of that. So if you were to type all that into your calculator, assuming your calculator can handle that number, that would equal 1,323. Phew, that's a lot of big numbers. Let's do the same question, but this time let's use our rules. Okay. So if I start off with, let's see, I'm just going to rewrite the question. X to the 6, y to the 4, all to the exponent 1/2. I'm going to bring that 1/2 exponent in first. Okay. So that means I'm going to have x to the 6 times 1/2, y to the 4 times 1/2. That equals, well, 6 times 1/2 is just 3. 4 times 1/2 is just 2. And now if I sub in, we get, what's x? 3. 3 to the exponent 3. Y is 7 to the exponent 2. 3 to the exponent 3 is 27. 7 squared is 49. Final answer, 1,323. So this way I'm dealing with much smaller numbers if I simplify using my rules first. Okay, let's do another question that's from right beside some of your homework. So I think I gave you some of the questions from 7. Let's do bracket 25 a to the 4 to the exponent -1 all over bracket 7 a to the -2 b all squared. And I want to do this for when a is equal to 11 and b is equal to 10. So again, I want to simplify using my rules first. So let's say, well, that's -1, so that's all going to come down into the denominator. So you get 25 a to the 4. And let's see, let's bring this 2 in here. So we've now got 7 squared, a to the -2 times 2, and b to the 2. Okay, so there's a lot there, but don't worry, this will simplify. Oops. So let's see, that's going to equal 1 over 25 times 7 squared is 49. Oops. And then I have, let's look at our a's. We have a to the 4th times a to the -4. Ooh, those guys are going to disappear. Times b squared. So all of this is going to equal 1 over 25 times 49. 1,225. A to the 4 plus a to the -4. Well, that's just a to the 0. So those guys are gone. B squared. So now when I go to actually evaluate it, I'm doing 1,225 times, what was b, 10, times 10 squared. Well, 10 squared is 100, so you get 1,225. Pop a couple zeros on the end, and you got it. And there we go. Okay, so here's just the whole question all together. Right, let's do one last example. So this one's just number 9C from page 237. We have a very complicated situation in here to start with, but don't worry. All we need to do is just keep using our rules, keep simplifying it down, and we've got this. Okay? One little step at a time, and there's more than one way to do this. So if you answer your questions a little bit differently than I do, it's fine. You're good. So let's see. I'm going to get rid of this root and I'm going to write it as the, and I'm going to split it up. So I've got root 64, and then I have a to the 12 over 2. Maybe I shouldn't do it that way. Oh well. Over a to the 1.5 times negative 6. And everything is to the exponent 2/3. So all I did going from this step to that step in the numerator is I took that whole square root of 64 a to the 12 and I just broke it up to 64 root a to the 12. And then I said, well, I can just write that all as a fraction. So I've still got the root 64. I haven't solved that one yet. And then I just wrote 8 as the 12 over 2. Okay. Now let's see, next step. Well, the square root of 64 is 8. 12 over 6 is the same thing, or sorry, 12 over 2 is the same thing as 6. I could have simplified that off to the side too. You see with these asides, they're so nice. It just breaks it down so much smaller for me. And then 1.5 times negative 6. Well, that one's a simple one too. 1.5 times 6 gives me negative 9. So that gives me a to the negative 9. So already what I've got going on in this question looks so much nicer. Okay. Let's make my page a little bit longer here. This is a long question. So let's see. We've got some a's in here that I can put together before I worry about my outside exponent. So I have 8a to the 6 minus negative 9, all to the 2/3. So that gives me 8a to the 15, all to the exponent 2/3. Oh, now it's looking so much more simple. Now I'm going to bring my 2/3 in. Now it is time to bring in that outside exponent. So it's going to come into the 8 and it's going to hit the a. So I'm going to get 8 to the 2/3, a to the 15 times 2/3. So let's see, the third root of 8 is 2, so that's going to give me 2 squared. 15 times 2 gives me 30 over 3. All right, 2 squared is 4. 30 over 3 is 10. Final answer. Okay, let's take a big look at that one. Big overall look. Where'd my cursor go? Where's my cursor? So there we have it. Big nasty question. You can simplify your numerator if you want over to the side. So that's an aside. Bring it back in. Put your a's together. Bring in your last, your exponent on the outside last. Now that things are much more less complicated. And there you go. All done.